Synthesis and characterization of metal bionanofibers composed of cobalt nanoparticles embedded in Opuntia Ficus-Indica fibers by Lizbeth González, Rosario Mejía, Guadalupe Olayo, Cruz, Daniela Legorreta, and Carlos Lara from Tecnológico de Estudios Superiores de San Felipe del Progreso and Instituto Nacional de Investigaciones Nucleares. The present work developed a grand synthesis method to obtain cobalt nanofibers based on the reduction in the presence of Opuntia Ficus-Indica extract of cobalt particulate material in the presence of the Opuntia Ficus-Indica extract with a aggregate volume of 160 milliliters and a reduction percent of the chemical agent is 35%. The objective of this work is use Opuntia Ficus-Indica extract as a reducing agent in the synthesis of cobalt particles that provide active site for obtaining nanofibers. The methodology to be followed is first to obtain extracts, then to mix the Opuntia Ficus-Indica extract with the cobalt solution. Then synthesis is carried out adding the chemical agent by dripping. Finally, the characterization of the material and the obtaining of results are carried out. Physical properties. The cobalt nanoparticles formed that deposited on the fibers contained in the Opuntia Ficus-Indica extract, and finally a black precipitate with magnetic characteristics is formed. When dried, a powder with magnetic properties is obtained as shown in Figure 1, 2, and 3. Magnetic properties. The magnetic field is applied at room temperature for the cobalt nanoparticles, where it can be seen the effects of magnetic disorder on the surface of the cobalt nanofibers is shown in Figure 4, 5, and 6. Electromagnetic absorption and reflection. The nanofibers will irradiate with 3 wavelengths. The surface of the material is irregular shaped. The responsible of the surface show reflection of the color of the incident beam and enlarged particles. The dark areas are due to the tendency to absorb cobalt nanofibers. These have a high reflection. They allow reading up to 60% of the supplied beam. This behavior is due to the metallic character and the crystalline structure, as shown in Figure 7. Morphologic properties. In Figure 9 show an image of the synthesis particles. The compound is formed by very small agglomerate nanoparticles with spherical morphology. To determine the average size of the nanoparticles in Figure 10 was prepared, which was adjusted with a log normal distribution, obtaining that the nanoparticles have an average size of 113 nanometers. Elemental chemical composition mapping. In the elemental composition mapping section, it is shown in Figure 12. Next, superficial atomic energy states. Figure 30 shows the spectra of the Opuntia Ficus-Indica extract, as well as cobalt nanoparticles and cobalt nanofibers. The observed spectra were made with three Gaussian curves from the erosion at 0 seconds, 30 seconds, and 60 seconds. Figure 14, 15, and 16 show the curves for the carbon, argene, and cobalt orbitals, respectively, and the Opuntia Ficus-Indica extract cobalt nanoparticles and cobalt nanofibers. In electric conductivity, the electric conductivity decreased for 3 to 5 as the temperature increased, as shown in Figure 10, dependence of resistivity against temperature. In conclusion, it's possible to synthesize nanofibers using Opuntia Ficus-Indica extract as an effective cobalt reducing agent thanks to the active sites provided by the extract so that the cobalt nanoparticles adhere to the fibers and thus obtain cobalt nanofibers. The percentage of the reduction of the chemical agent was 35% compared to the synthesis carried out without extract. The properties of the cobalt nanoparticles are hemispherical in shape with an average size of 130 nanometers. In addition to having metal and magnetic characteristics, for which the cobalt nanofibers have high reduction allow up to 60% of the subplate being to be carried beneath thanks to the metallic characteristics and the crystal structure of cobalt nanoparticles. Acknowledgement to Tecnológico Nacional de México, Tecnológico de Estudios Superiores de San Felipe del Progreso, and Instituto Nacional de Investigaciones Nucleares for providing the resources and tools to carry out this research in each of the stages to achieve the state objectives.